Global warming. As people all over the world have begun to go green, the subject of global warming has gotten a lot of media attention. The Earth's climate change has become increasingly dramatic during the past 200,000 years in which modern humans have inhabited the Earth. The drastic reduction in the amount of ice on Earth since the Industrial Revolution is evidence that humans are the cause for the increase in temperature. Since the Industrial Revolution, humans have emitted large amounts of carbon dioxide from the combustion of fossil fuels. Carbon dioxide is what is known as a greenhouse gas because it traps heat in the atmosphere. The sun emits energy which travels through space to Earth. Some of this energy is reflected off of the atmosphere, but the rest of the energy enters the atmosphere and is reflected off of the Earth's surface. The problem arises when the energy that has been re-radiated by the Earth tries to escape the atmosphere. The energy is trapped by greenhouse gases, which include ozone, methane, nitrous oxide, and carbon dioxide, which prevent it from exiting the atmosphere. The excess energy in the atmosphere causes an increase in the global temperature and climate change worldwide. The U.S. government has attempted to regulate carbon emissions. However, efforts must also be made to reduce the amount of carbon already in the atmosphere. Carbon sequestration is a group of strategies that can be utilized to accomplish this reduction. There are two types of carbon sequestration: biosequestration and point source. Biosequestration involves several natural processes by which the Earth's resources become carbon sinks. The Earth's main natural carbon sinks are plants, the ocean, and soil. The process that allows plants to store carbon is called photosynthesis. During photosynthesis, plants use the sun's energy to convert water and carbon dioxide into sugars such as glucose and oxygen. The oxygen is released as a byproduct, but the carbon-containing sugars remain in the plant. When forests are cut down, this carbon is re-released into the atmosphere, which is why deforestation is a prominent issue. Instead of cutting down forests, people should actually plant more trees, as well as other plants, in order to increase the amount of carbon removed from the atmosphere through photosynthesis. As was mentioned before, the ocean is also a carbon sink. The ocean utilizes two processes which enable it to store carbon. These processes are referred to as the biological pump and the solubility pump. The biological pump is essentially the same as photosynthesis, except instead of trees and bushes, the organisms undergoing photosynthesis are phytoplankton in the euphotic zone of the ocean. The euphotic zone is the layer of the ocean nearest to the surface. These phytoplankton store carbon within themselves, and when they die, they sink to the deep ocean, bringing the carbon with them away from the surface. One process to increase the biological storage potential of the ocean is iron fertilization. During iron fertilization, micrometer-sized iron particles are added to the ocean in the form of either iron oxide or iron sulfate. The iron particles encourage the growth of phytoplankton, which increases the rate of photosynthesis. The solubility pump is basically the process by which carbon dioxide is dissolved in the ocean water at the surface. Carbon dioxide is more soluble in cold water, so the solubility pump is more effective in colder regions. The Earth's third natural carbon sink is soil. Carbon is naturally found in soil. However, current agricultural practices have depleted the soil's carbon storage potential. In order to maximize the amount of carbon that soil can hold, alternative agricultural methods are used. These methods, collectively referred to as regenerative agriculture, include no-till farming and cover cropping. Regenerative agriculture also includes growing crops organically without the use of chemicals. No-till farming is a technique in which crops are planted without plowing and harrowing the field. This process prevents the loss of water, organic nutrients, and carbon dioxide, which greatly improves the soil quality. Cover cropping is a method in which crops are planted to maintain soil quality and soil fertility. Both of these methods improve the ability of soil to act as a carbon sink by improving the overall soil quality. Carbon capture and storage is a process which removes carbon from point source emissions. This carbon is then typically stored within deep geologic formations. Carbon capture processes are not widespread due to the capital costs of separating carbon from the air. Existing technology is expensive and is not feasible for carbon removal on a large scale. For this reason, affordable and innovative carbon capture processes are being pursued. There are three general types of carbon capture processes: pre-combustion, post-combustion, and oxy-fuel. In pre-combustion carbon capture processes, carbon is removed from the fossil fuel source prior to its ignition. Carbon is separated through initial conversion of the fossil fuel to syngas. Syngas is fuel which contains a mixture of hydrogen, carbon monoxide, and carbon dioxide. Hydrogen and carbon dioxide are separated at this stage, and hydrogen is combusted to produce energy. It is estimated that a combined cycle plant with pre-combustion processes would cost twice the amount of the same plant using natural gas. This eliminates incentives for industry to adopt pre-combustion processes and highlights the need for innovation. Post-combustion processes are presently the most commonly used for capture carbon. After combustion, carbon-containing emissions are put in contact with an amine solution. The amines then absorb the carbon. The carbon dioxide is recovered through heating and the amine is recycled. Gas emissions are high in temperature, high in volume, contain various impurities, and contain carbon dioxide at relatively small concentrations. Because of these factors, large equipment is required and large amounts of energy must be expended to effectively separate carbon. Efforts to increase efficiency are being made that include modifications to equipment, use of better solvents, and modifying plant designs to reduce costs. Oxy-fuel combustion is a process which combusts fossil fuels in pure oxygen. This process yields carbon dioxide and water as byproducts. Carbon dioxide is then easily separated and removed. Nitrous oxide emissions are also removed in this process. Combustion temperatures are much higher in pure oxygen, which increases the energy demand significantly. Currently, diluents are used to reduce the required temperature. This may allow for existing boilers and other equipment to function under this process. Oxy-fuel combustion, like other carbon capture processes, is limited by cost. Cryogenic air separation and flue gas recycling increase the energy required to separate oxygen. Innovations are being explored in ion transport membranes. These membranes are ceramics containing a crystal structure that have oxygen vacancies. At a high temperature, this non-porous material will allow oxygen to pass through it. These membranes may provide means of energy and cost savings in the future of carbon capture. Carbon storage is critical to the ultimate removal of carbon dioxide from emissions. The most viable option for carbon storage is thought to be deep geologic formations. To achieve this, carbon must be compressed, transported through pipes, and injected into the earth. Sedimentary basins are desirable for this type of storage. Permeable sandstone layers allow the injection of carbon, while impermeable layers of shale and evaporite trap the carbon in place. Carbon can be stored in different phases: liquid, gas, or solid. The phase is determined by many factors, including the properties of the geologic formation. One of the benefits of deep geologic storage is enhanced oil and natural gas recovery. Oil and gas reservoirs offer ideal formations for carbon storage. When carbon is pumped into these formations, trapped fossil fuels are released and can be subsequently recovered. In this way, carbon storage offers a potential economic benefit. More research is needed in the field of carbon storage. Leakage within formations is a serious environmental concern. Monitoring techniques are now being studied which will hopefully aid in efficient and environmentally sound storage. The amount of carbon dioxide in the atmosphere must be decreased if Earth is going to continue to sustain life. This reduction can be accomplished by promoting the Earth's natural carbon sequestration processes, as well as by mitigating the carbon emissions of energy production and consumption. Both biosequestration and point source carbon capture will require a financial commitment in order to be more effective. However, the initial extrinsic cost should be considered small when compared to the intrinsic value of an atmosphere with low concentrations of carbon dioxide.